Shoes have existed for quite a long time, with some like these dating back to around 5,500 years ago. That being said, there have even been some studies on human skeletal records that show that shoes might have existed 40,000 years ago. That's a long time. Now, with shoes being invented all the way back then, there is still one problem that we have to deal with to this day. And that's stinky shoes. Stinky shoes definitely aren't on the top 10 list of problems that need solved in this world. However, they can be annoying and even embarrassing at sometimes. Now, probably the simplest way to get rid of stinky shoes is to wash your feet and shoes often. The stink in your shoes actually comes from bacteria that is feeding off the sweat off your feet. So if you clean those both, you should be good. However, this method is kind of tedious and boring to a lot of people, so I'm gonna try to fix it today with this. This is version 1 of my bacteria killing shoe display case. Now, I tested this thing a few weeks ago and the results are actually pretty surprising, but before I show you guys that, I want to show you guys how I built this thing. Starting with the sketches. At the beginning of every project that I do, I like to create some sort of sketch, and this project was no different. I start by grabbing a piece of paper and a pencil, and after around half an hour of thinking and sketching, I created these. So this was basically the game plan for the entire project. If we take a look at this one here, we can see a basic overview of what I wanted. Basically, I just wanted a box that would open up and have your shoes slide out in such a cool way. Once they're in, that's when the disinfecting process would happen. This is what the electronics inside was gonna look like. You have your power supply here, your control board, all that stuff down here. And originally I was thinking of having a disinfectant spray that was gonna automatically spray out over the shoes. However, you'll later see that I swapped that out for something else. This is a side view of what the electronics was gonna look like. You can see we have our power supply here, a cooling fan here, your linear actuator here, spots to plug in here, servos up there, all the bed, door, all that stuff. This was basically what I wanted it to look like. Now, while my sketches were pretty great for getting my ideas out on paper, you may have noticed that there weren't any dimensions. So I gathered up the main components and started to lay them out for measuring. This was a pretty straightforward process. I basically placed everything like how I had them in the sketches. Also, that is bug spray right there, but don't worry, I didn't use it in the actual build. I just needed something to act as a placeholder for the disinfectant spray. I then used tape to mark where I wanted the walls to go, and with that, basically everything was measured. Once that was done, I then moved over to Onshape, which is where I made this simple mock-up. Now, this wasn't functional, but it was something for me to look at and decide what I wanted to add next. Now that I knew kind of what I wanted it to look like, I then started to create some of the components, starting with UVC LEDs. UVC, or ultraviolet type C light, is a special type of UV light that's in the 200 to 280 nanometer wavelength range. Now, I'm not going to get into the science of it, but this light can basically kill bacteria and is used in areas like hospitals, water treatment plants, and air purification systems. So I thought it'd be a perfect thing to add to the shoe display. Originally, I was thinking of finding something on Amazon, but everything was either not the right size, not the right wavelength, and I just couldn't really find anything I liked. So if you want something done right, you've got to do it yourself, and that's why I decided to make a custom PCB. I start by finding these small UVC LEDs, which were in the range that we needed, and I then used JLC's PCB editor to create this. Now, this is where I'm going to eat my words because apparently I didn't know enough about circuits at the time to get this to work how I wanted it to. You'll see later on that the LEDs actually stay on and you can't turn them off, and I think that's maybe because I might have placed the pull down resistor in the wrong spot, but I'm not too sure. Anyways, I then moved on to getting the clear door designed. I originally wanted to have this resin printed, but after looking at the print cost, I decided to make this myself as well. To be fair, this part was massive, so I totally understand why it costed so much. To fix this, I then ended up cutting some holes in the 3D model, which then allowed me to put plexiglass sheets inside. I also decided to use a transparent filament to print the shell in. Now, transparent 3D printer filament isn't really transparent, and that's just due to how air gets caught in between the layer lines and stuff, but I still thought it looked cool. Now, you can fiddle around with different nozzle sizes and printer settings to get the print to be more transparent, but I didn't want to do all that, so I just printed it out and then connected all the pieces together with carbon fiber rods. Once everything was put together, I then cut the plexiglass sheets to the size I wanted them. Unfortunately, I didn't have the right tools for this, so I kind of just jerry-rigged it. Despite that, I thought the pieces looked pretty cool inside, but I didn't do any gluing yet because I wanted to add this UV-resistant film over top of them. UVC lights, like the ones that I was going to use in this project, can actually hurt your eyes if you look at them. So I found this UV-resistant window tint on Amazon, and I wanted to put that on the plexiglass sheets. Now, I didn't know this at the time, but that window tint wasn't going to work anyways. It's probably good for tinting your windows like what it's meant to do, but for special applications like this, it was probably not going to protect my eyes too well. So if you guys want to create something like this, make sure you take the time to get the right eye protection. It could probably save your eyes. Now, like I said, I thought this was going to work at the time, so I bought the window tint and I put it on the plexiglass sheets, and it actually ended up looking pretty cool. There were a few air bubbles, but that was okay. After finishing up the door, there was another pretty important problem that we needed to solve, and that was, how is the microcontroller going to know when there's a shoe inside of the shoe display? Now, we could have added an ultrasonic sensor like this one here, which would have detected when a shoe is in front of it, and then it would start the cleansing cycle. But this kind of adds more complexity to it, and with some shoes being made out of cloth, you might actually have problems with the sound being absorbed and not making it back to the receiver here. So I decided to go with a simple button, but not a button like this. This is actually a little bit too hard to push down. Instead, I made a few prototypes, and I eventually landed on this pedal looking button. Now the idea of this is pretty simple. When you push them together, the two pieces of copper tape touch each other, which completes the circuit, which then lets the microcontroller know when there's a shoe inside the box. It's also extremely light, and you don't really have to worry about your shoe not being able to push it down. After I made this sensor, I then moved on to figuring out how we're gonna spray the disinfectant. And to solve that, I just simply got rid of it. The idea was great, but it was gonna be kind of hard to do. For example, depending on where your shoe is sitting in the box, they might or might not get sprayed, and usually you want the spray to be inside your shoe, not on top of them. So I decided to get rid of that, and I swapped it out for this. This is a special push latch mechanism that I made, which houses the cartridge for chlorine dioxide. Chlorine dioxide gas is actually used in several different industries for its cleaning and sterilizing properties. And you can actually buy these little tablets that you dissolve in water, which creates the gas. That being said, if you do want to create something like this as well, make sure you're careful because this gas in high concentrations can be kind of dangerous. For this project, most of the gas had already evaporated before I even put it inside the shoe display, but still be careful when working with this type of stuff. Anyways, I think this is probably one of the coolest mechanisms in this project. I really liked how I designed it, and I really think it's cool how it works. Anyways, the idea behind this component is that this fan will blow the chlorine dioxide gas into the box, which should get rid of a lot of the bacteria that's hiding underneath the fibers inside of your shoes. It's just another way to get rid of the bacteria along with the UVC lights. Now at this point in time, some of the components I had ordered had started to arrive. For example, we received the servo that was going to open and close the door, so I started to mess around with that. I first wanted to see if it could even lift the door, which it could, but it wasn't the best. After looking at this now, I probably should have added 2 servos instead of the one in the middle, but that's just something to keep in mind for the future. Now, after running this test, I found another problem that was kind of screwing this whole thing up. And that was because since I decided to place the servo right here, the shell was actually going to clip through the top corner of the box. As you can assume, this is not ideal, and there are actually probably a bunch of different mechanisms that probably would have fixed this, but I was getting kind of tired of tackling this door problem, so I just made a mechanism that would move that corner out of the way. I introduced to you the flap mechanism. Pretty good name, right? Anyways, I designed, printed, and assembled the flap mechanism to move that corner out of the way so that the door could open up. When the door closed, the flap would come back down, leaving no large gaps for the chlorine dioxide gas to escape through. Now, alongside the push latch mechanism, this is probably one of my favorite things I created. It kind of reminds me of some sort of transformer or something. However, I didn't add the ultrasonic sensor for detecting shoes because it made things more complex, and the same was with this. Having this small flap up there was just another potential point for failure, and like I said before, there were other ways to solve this problem. You'll actually see later on that I end up using a special arm for this, which works way better. Now moving on from the door, if you remember back to the beginning of this video where I was breaking down the sketches, you might have noticed these small little dots. Now these small dots were supposed to be some sort of indicator LEDs that would let you know what mode the disinfector's in. And to add them, I was planning on using this old LED strip that my friend Brody sold me. However, after I bought these from Brody back in like 9th grade, I only ended up using them a few times, and then I ended up just shoving them in a drawer under my bed. Now these probably would have worked fine if I had rolled them up properly. However, as you can probably assume, I did not. And because of that, I pretty quickly found out that most of the connections were actually broken, so we weren't going to be able to use these. Now, this did suck, but luckily one of you guys reached out to me on Instagram and suggested these lights right here. The things that I like about these ones right here are the fact that they are addressable, meaning I can control the color of each individual LED, and they also run on 5 volts, which is pretty good compared to the 24 I would have needed to run these things right here. If you guys want to pick some of these up, I'll leave a link to them in the description, but I just want to give a big thanks to that guy for suggesting these. Now, along with these parts right here, there were a few other large components that we needed. However, I couldn't make them myself, so to help us get those, I'm going to be telling you guys about today's video sponsor, JLCMC. So for this project, we're going to need a few extra things, such as a linear actuator for the base, drag chain for the UVC LEDs, and a few fans to keep everything cool. Now, to find this stuff, I'd usually have to hunt around several different websites, but with JLCMC, we don't have to do that. Instead, we're just going to simply head over to their website, search up the part that we're going to need. So for this, we're going to need a linear actuator. Then we just select our sizes and add it to the cart. Now that's one part added, but let's get the other ones added. There's the fans, and there's our drag chain. After I found everything I wanted, I'm then gonna go and click on the cart, select the items that we're gonna be getting, and secure in the checkout. It's as simple as that. Now, along with the ordering process being super easy, the parts actually got here super fast. I think I waited around 5 days after ordering them to receive them, and that's actually pretty dang good, especially where I am at, which is like basically the middle of nowhere. After receiving the parts, I then did a little unboxing segment, and let's just say I was impressed. All of the parts were extremely high quality and neatly packaged. If you've ordered custom PCBs from JLC PCB before, then you probably know what I'm talking about. Everything just felt super premium and it was really high quality. Now with this order, we were able to get a few crucial things. For example, we got this super nice steel linear actuator for the shoe bed. We also got some fans, which we're gonna be using for the cooling and for blowing the chlorine dioxide gas into the box. We also got this high quality drag chain, which we're gonna be using to hide the wires for the UVC LEDs and the shoe sensor. Speaking of UVC LEDs, I also got those made with JLC as well, which made this whole ordering process even easier. Now that's just a few things that JLCMC has, but they also have a lot more stuff. They have gears, sensors, bearings, basically anything mechanical they probably have. Anyways, if you got a project coming up and you need some high quality mechanical components, please register your account using the link on screen or in the description. And with that, you'll get $60 off on your next order, plus monthly coupons. Big thank you to JLCMC for sponsoring this project. Now let's see what these parts can do. Now before we start putting this thing together, there's one more thing that I wanted to test, and that's the fans. If you look closely, you can see that these fans only have 2 wires, which means we're gonna have to use some sort of transistor to turn them on and off. Now I haven't used a whole lot of transistors or fans in my projects yet, and because of that, this is where I ended up making a mistake. You can see in this video here that I'm controlling my fan with my microcontroller and MOSFET, which is okay. We could actually connect this up to our UVC LEDs and turn them on and off that way. But when using a fan, you need some sort of protection like a diode. When the fan turns off, the magnetic field collapses, which causes a back EMF to actually flow back up through the wires, which could break stuff. And it did. It actually ended up breaking one of my ESP32s, which is okay, I just swapped another one in, but we needed to get some sort of diode in there ASAP. So later on, you'll see that I did go ahead and do that. Anyways, I've got most of the box design here, so let's start putting this thing together. Alright, so it's starting to look more and more like what I envisioned. You can see here that I'm adding in the electronics, and this was quite the process. I wanted things to look organized, but I was also programming it as I went, so with testing and stuff, things ended up being a little bit more messier than I expected. You can also see me here testing the arm that I was talking about earlier. This thing was a super simple solution, and I think it's actually kind of genius how this thing works. Basically, with how I angled these slots for the bearings here, when the arm lifts up, the door slides out a little bit, which gives it enough clearance to clear that corner there. You can also see that this thing connects to the box in 2 different places instead of just the one that we were originally going to have. And this actually gives the door a little bit more support, which is always nice. Now, I wish I added a spot for a second servo right here, and you'll see why in just a minute. But besides that, I think this was a pretty nifty solution for this problem. All right, we got a few more things to add, so let's get those in real quick. Finally, after several months of designing, building, and testing this thing, we nearly have something to show. And I say nearly because of this. After I got everything put together, I then decided to glue the plexiglass sheets to the door. However, immediately after pressing the button to open the door, I found out that the plexiglass sheets actually made the door too heavy to lift. This is why I should have added the extra servo. Now, this was super annoying, but I had a few temporary solutions for this, starting with these. I basically just made these simple frames that were able to hold the UV film inside. With these, we would at least have some sort of protection from the UVC LEDs, but with just my luck, they were too heavy as well. I don't even really know why this is a huge problem. Like, these things are so light, so much lighter than the plexiglass sheets, that I feel like they wouldn't take this thing down, but whatever. If there's one thing that I learned from this project, it's that I gotta start over-engineering my stuff a little bit more often. That way we aren't worrying about stupid problems like this one. Anyways, I said I had a few temporary solutions, and this next one was one that I was actually trying to avoid. Now, to be honest, I kind of like the look of it with no panels attached. I like being able to see your shoes in there. I think that's pretty cool. But we can't do that because we need something to keep the chlorine dioxide gas inside. And that something is saran wrap. This saran wrap is basically weightless, and it's pretty easy to stretch over the openings in the door. Kind of like this. Wait a second, now that I'm thinking of it, I probably could have done the same thing with the UV tint. It was really just the frames, I guess, that were probably too heavy. I'm assuming the tint itself wasn't actually that heavy. Just a second, let me try something real quick. Well, I guess that could have worked. Obviously, I did not try to get that thing to look nice, but you did see it open up. You guys are probably wondering, why didn't I just cut out the pieces and then glue them into the slots? Well, I actually did give that a try before I made these little pane things right here. And I just found out that it was so dang hard to cut the stuff. And that's why I made these, so that I could get it all fitted together and then cut the stuff afterwards. Well, anyways, back to the saran wrap. Now, the saran wrap was gonna work. It was light enough, it kept the gas in, but it had zero UV protection. Now, if you guys are planning on building this, I would use this video as kind of a guide on what not to do. And this is one of those things that you shouldn't do. UVC light is not good for your eyes, and having zero protection from it is definitely not good for your eyes. So please do not attempt to do this. Unfortunately, it was the only option that I had thought of at the time. Obviously, you could tell that there was other options I could have done, but that's why I ended up going with it. From here on out though, I'm definitely gonna be setting up some better safety standards because I do not wanna be losing these eyeballs. Anyways, now that we have at least something on there, I can officially say that version 1 of the bacteria killing shoe display is complete. Now this thing is super cool, and to help you guys better understand how this thing works, I want to give you guys a breakdown of the different modes, starting with stationary mode. Stationary mode is the mode that's in most of the time, and you can tell that it's in that mode by the pulsing white light. Stationary mode is the first mode that you see when you turn it on, and it's also the same mode that you'll see after it gets done sterilizing. Speaking of sterilizing, the next mode is sterilizing mode. Sterilizing mode is activated when a shoe is placed inside the bed and the door closes. Once activated, sterilizing mode runs for a total of 1 hour and operates by turning on and off the UVC LEDs, along with blowing the fan in the back here. This fan then blows through this cartridge here, which holds the chlorine dioxide, which then blows the chlorine dioxide into the chamber. You can also tell it's in sterilizing mode by the light bar down here turning to a pulsing yellow color. However, like I said before, once the full hour is up, it will then turn back to a white pulsing color. If the hour-long runtime is not enough for your shoes, then you're probably just going to want to open and close it again. This resets the system and starts the sterilizing cycle again. Now those are the two main modes. However, there is a third one that's less used, and that's debug mode. You can activate debug mode by holding down on the open and close button here for 5 seconds. You can tell you're in debug mode when the light turns to a solid light blue color. In debug mode, you can update code by sending it through the over-the-air updates, or you can test simple functions by using this simple UI that I made. To exit debug mode, all you gotta do is just turn it off and then back on again. Also, I forgot to mention it, but you open it by pressing this large button on the side right here. The light bar will then turn to a pulsing green, which lets you know that it's opening up. Also, once you press the button, you have around 30 seconds to get your shoes inside the shoe display. After that, it'll automatically close. You can also manually close it by pressing the button again. However, I thought an auto close would be kind of nice. Anyways, that's basically it for the different modes. Now, I was gonna test this with a pair of stinky shoes, but I couldn't find any, and you guys would also have to take my word for if it killed any bacteria or not. But lucky for you guys, some genius reached out to me on my shorts channel and suggested that we use petri dishes for the testing. So I got some. I started by getting some samples from my own shoes, which I forgot to film. Sorry about that, guys. But don't worry though, I also got some samples from my sister's shoes, and that's what you're seeing right now. I also got several other samples, like some pumpkin mold and some leaves and stuff like that. But I did actually end up testing them inside the shoe display, so just ignore what you see here in this next clip. Anyways, I then let the bacteria grow for about a week, which is then when I filmed this. All right, so as you can see here, we have 6 different petri dishes. The top 3 are different bacterias that I got from random things. This one is my shoes. My shoes do not stink. However, I do wear them nearly every day whenever I go outside. And yeah, that is just gross. Like, I'm for sure gonna be throwing my shoes in here if this works. But yeah, that's terrible. Now these 2 right here are from my sister's shoes, and these are her shoes that she uses for volleyball. So they're shoes that probably gonna get sweat in them and stuff like that. As you can see, it looks a little different. Like, here are my shoes and here are her shoes, and the difference is kind of insane, but this looks pretty gross here. That's the right shoe, and then of course got the left shoe. I should have gotten more of my shoes, but yeah, it is interesting to see the difference that there is here. Now to test this out, it's going to be a little bit difficult. That's why I actually went and made this specific tool for this. Basically what this does is it pops into the middle rail like that. And then these little things here are meant to hold in the UVC LED things. Oh, that just broke. Anyways, they're supposed to hold that, and then down below is where the bacteria is supposed to go. So they're slot in like that and like that. You'd obviously take off the caps of them so that they can get in there, but the UVC light is going to shine directly down on them. Plus you have the chlorine dioxide gas blowing in from right back here. That's going to blow in, and then it's going to stay in the chamber and hopefully kill this bacteria. So what I'm going to do right now is actually get pictures of all of the different bacterias right here. That way we can compare them to see what they look like in the chamber after a few days. But yeah, let's get to it. So I left the bacteria inside the box for about a week. During this week, it was basically in sterilizing mode the entire time. And by the end of it, you could tell that something had happened to the petri dishes. These are some of the pictures that I got on the last day of testing. And if we compare them to the pictures I got on the first day of testing, you can clearly tell that the agar gel stuff started to shrink. Now I looked this up, and it's probably due to the access of air they have and also the UVC lights being directly above them. However, to be honest, this is kind of hard to tell if we killed any bacteria or not. It's not like the bacteria is just gonna disappear. So after finding out this wasn't the best way to test this, I changed my method and did the test again. This time I collected 2 samples from my shoes. After collecting both samples, I then put one in the box and then left one outside of the box. Now the one outside the box is supposed to kind of simulate how my shoes are right now. I just take my shoes off and put them away. That's it. And the petri dish inside the box was supposed to simulate what would happen to my shoes when I put them in the box. Now if things go to plan, the petri dish outside the box should have bacteria inside of it, while the one inside the box shouldn't. Now there's only really one way to know this, so I ran this test for about a week, and now I've got these right here. So for starters, we got the bacteria that was outside of the box. You can see that there's a bunch of different things growing on there, and it's pretty gross, to be honest. We then have the petri dish that was inside the box, and it's kind of crazy. If you look, there's nothing. Like, you can see I swapped it there, but there's nothing. Also has shrunken a lot more than the one that was outside the box, you can see here. So I think that's definitely has something to do with the UVC light. But yeah, that's just insane to me how well the UVC light killed the bacteria. I also didn't really refill the chlorine dioxide up on this second test. So this was mainly just UVC light right here, which just shows how dangerous it can be to your eyes. Now, obviously the UVC light is gonna work best when it shoots directly at the bacteria. In your shoes though, you have different layers of fibers and stuff, and some bacteria can be underneath fibers and things like that. That's why I think the chlorine dioxide gas would be a good thing. Kind of hard to test the chlorine dioxide gas unless we just test the gas without the UVC lights, I guess. But yeah, it's just insane to me how well that worked with this test right here. It's also insane to me how this came out of my shoe. Like, my shoes do not stink, but apparently there is a lot of bacteria in there, so that's really gross. So yeah, those results were pretty interesting. Now, to make this thing, I had to go through a ton of challenges. Matter of fact, I had to simplify and cut out a lot of stuff during this video, just because if I didn't, this video would be like 5 hours long. But despite some of these challenges being super annoying, especially that door, if you know what I mean, this whole project was a really good learning experience, and I feel like I learned a lot more on just how to make my own stuff, you know what I mean? If you guys want to build this thing, I'm going to be leaving a link in the description below with all the code, STL files, parts, stuff like that. Though keep in mind, they're going to be the exact same way that I left them, so if you try to build it the same way as me, you're probably going to have the same problems. I'd really just use this whole thing as kind of a stepping stone to build something better. I think it'd be kind of cool to do a version 2 of this project that fixes a lot of these problems, like the door and all that stuff. But let me know what you guys think in the comments below. Would that be something that you guys would want to see? Now, I said I'm going to have links to all the different parts I used, but I guess I kind of lied there because I'm actually going to be leaving out a few things, starting with the PCBs for the UVC LEDs. At the time, I didn't know anything really about designing that, and so the whole design just kind of sucks. I know there's probably somebody watching right now that can make a way better design than me. I'll leave a link to the UVC LEDs though, so you can go and find those and add them to your schematics. Also, I'm not going to be adding this protective film stuff. I'm not sure. I think this wasn't really the best. This is meant to tint your windows, not protect your eyes from this crap. So yeah, I'm not going to be leaving that down there as well. You're probably just going to have to find your own. So sorry about that. Once again, I want to give a big thanks to JLCMC for sponsoring this project. They're kind of the first big sponsor that I've had, and without them, this project wouldn't have been possible. So it means a lot to me if you guys use my link right here to get yourself $60 off on your next order, plus the monthly coupons you get when you sign up. If you guys enjoyed this video, please make sure you hit that like button and maybe even hit that subscribe button if you want to. You don't have to though, but if you want to, of course. Looks like my computer turned off. Anyways, with that, I'll see you guys all in the next video.